Suppose you wanted to find the labor demand curve for a firm or an industry or the whole economy. Well, we normally think of firms as maximizing profits, which we denote by the symbol pi, which is also what we use for inflation, which can be a bit confusing. But in this case, it's clear. Pi is profits, which is equal to the price times the production function of the firm, K and L, minus the cost of the inputs RK and WL. So that's maybe the profit function for the firm, and the firm finds the amounts of capital and labor that it wants to hire to maximize its profit. So we are choosing max of capital and labor to maximize this function. And you can see that more capital increases production, but more capital is costly. The costs are, and more labor increases production, but more labor also has a cost, which is L. So we're going to choose the optimal at K and L to maximize the profit function. And the way we do that is by using calculus. We take the derivative of this whole expression with respect to K and then with respect to L. So we have P f of K, which is just the marginal product of this is the marginal product of production with respect to capital, minus R equals 0. So that's our first condition, maximization condition. And we'll have P f of L minus W equals 0. That's straight from calculus, taking the derivative, the partial derivative of the equation. And this implies then that f of k equals r over p, and this implies that f of l equals w over p. F of L, sorry, the marginal product of labor equals the wage, and the marginal product of capital equals the real cost of capital. Now, these two equations both have f of L. One has f of L, the other has f of k. These are the marginal products. They depend in turn on capital and labor. So we have two equations and two unknowns, and so we could solve for the demand for capital and the demand for labor as a function of the wage and the real price of capital. So we'd get two optimal demand curves depending on the prices. In many cases, we'll just have one input into the production process. So we have P(f) of L, say, minus WL is what profits are. So the choice for the firm is to choose L. So it chooses L so that the marginal product of labor, sometimes we can write it like that, or we can write it P(f) of L, the marginal product of labor, minus W equals 0, or alternatively minus W equals 0. So that's just saying that the marginal product of labor has to equal to the wage. Now, if we had a particular functional form for this, we could then solve for the optimal wage. For example, suppose that our profit function was given by P L to the 1/3 minus WL. Those are our profits. We could put this in Excel and find out which level of L are the profits maximized, right? So we could have different levels of L, and we could see when they were maximized if we knew what a value of P was and a value of W was. Or we can just use calculus and say that the partial derivative of profits with respect to labor is equal to P times 1/3 L, 1/3 minus 1, minus W, and set that equal to 0, and that then is our equation for labor, the optimal labor demand. We can simplify this. We can have P times 1/3 L to the minus 2/3 minus W equals 0. And we can simplify this further. I'm just going to erase up here, give myself a little more room. And we have we have P times 1/3 1 over L to the 2/3 equals W. Well, that's the same thing as 1 over L to the 2/3 equals W over P, 2W over P, and that's the same thing if we invert everything. L to the 2/3 is equal to P over 2W, and that's the same thing as we raise everything to the 3/2. L equals P over 2W to the 3/2. So that's our labor demand curve. Labor depends on the wage and on the price. Notice that labor demand is higher with a higher price and is lower with a higher wage. That's exactly what we'd expect. The higher the wage, the less labor demand it is. The higher the price of the product, the more labor is demanded. So this is a simple version of deriving the labor demand curve using calculus.